Hello, so today we are going to do this problem, non-decreasing array. Basically what the problem says is we get an array of numbers with n integers, and what we want is to check if this array can become non-decreasing, which means basically increasing by modifying at most one element. So we take the array, we can modify at most one element, and we want to see if we can make it non-decreasing or not by just modifying 0 or one element at most. And non-decreasing, of course, it's the previous element is smaller or equal than the next element. And that's pretty much it. So if you take a look at this example 4, 2, 3, we could just change 4 here, maybe make it 1, and that would make it increasing, right? Make it increasing, which is not decreasing. Here we can't, right? We have to modify maybe 2 elements. Maybe we have to do here, put here 1 and then put here 3 to make it non-decreasing, right? So here we can do it with just 1 element. And yeah, these are the bounds. So that's pretty much the idea. Now let's see how we can solve it. So one idea here, we'll take these 2 examples and use, but the one main idea here is that if you have a number at the previous position, right, bigger than the number at position I, then it's always more optimal to replace with the smaller value, because let's say this is I, right, and this is I minus 1, and we find that this is bigger, position I is bigger. It's always more optimal to replace I minus 1 with the value at position I, right, and make that the modification, because then numbers we will find here, if this array will return true, numbers we'll find here will be always bigger. So it's more optimal to replace with the smaller value. And so here we can just take the number at position I minus 1 and replace it with the number at position I and count this as a modification. So if we have a counter for the number of modifications, since we are allowed only at most 1, we count it here. Okay. However, there is one case where this is not working properly. For this example, it works because we find that, okay, 4 is bigger than 2, and so we replace 4 with 2. Right, and so now we end up with 2, 2, 3, which is non-decreasing, so this works out. However, with this array, it doesn't work out quite well because, okay, so this is smaller, so it's good. So we move to I being at position 2 here, and so we find that it's smaller, right? And this is I minus 1. And so we do what we did here, which is replace, and so what do we end up with? We end up with 2 here. But then the problem is I minus 2 is also smaller. So if we do the same thing as well, then 2 is also smaller than I minus 2. If we do 2 here as well, then we did 2 modifications, right? So the count here is 2. And we are allowed only at most 1. So this is not the optimal solution. Actually, we can solve it differently. What we can do instead is, for this 3, 4, 2, 6, we can instead replace the 2 with 4. So replace the element at position I with the element at position I minus 1. And so with that, we'd have here 4, and we'd end up with an array that has 3, 4, 4, 6. So it's sorted here. And so the conclusion here is that we can do only 2 modifications. Either replace the element at position I minus 1 with the element at position I, or replace the element at position I with the element at position I minus 1. And how do we decide? It's just by comparing. If the element at I minus 2 is already smaller than the element at position I, then we will get a sorted array, because we'll have the smaller number at I minus 2, the same number at I minus 1, and the element at position I, and then the rest, hopefully, it's sorted. But we'll check, and if count exceeds 1, then we'll return false. And then for the second case where we need to place the element at position I, we just need to check if I minus 1 minus 2, both I minus 1 and I minus 2 are bigger than I, then we need to just replace the number at position I with the element at position I minus 1, and that way we'll get a non-decreasing sequence there, right? And so here in this case, basically, if in addition to this, we have the number at position I minus 2 is bigger than the number at position I, then what we want to do is replace the element at position I with position I minus 2, right? And so this is what we need to do here. Okay. Okay, so that's pretty much it for this idea. Now let's code it up and make sure it passes our test cases. Okay, so let's solve it with this solution here. So we need to go through the array, right? And we'll go through from 1 to n because we'll check the number at position I minus 1, and so we need to start from 1. And here we need to initialize our count, and also we need to have n, which is equal to the number of elements. Okay, and then what we need to do is just do the check. So if number at position I minus 1 is bigger than the number at position I, then what we want to do here is, of course, increment the count because we found a correction or a modification that we need to do. But before finishing there, we need to check I minus 2. If it's bigger than at position I, then what we want to do here is replace the number at position I, so that we replace this element with I minus 1 instead of modifying both I minus 2 and I minus 1, which will give us count of 2 instead of 1. And so here we'll just replace with I minus 1. Otherwise, it means this is already smaller than the number at position I, so we can just replace I minus 1 with the number at position I, right? Since it was bigger, we replace, it becomes smaller, it becomes non-decreasing. And now, after each increment, if we increment count each time, we check if we incremented and we exceeded 1, because that means we need to modify more than one element. And so that means we need to return false because we can't make it non-decreasing with just one element, with just one change, right? And then at the end, we can just return if the count is still smaller or equal to 1, which is at most one element. And that's pretty much it. So let's run this, make sure it passes. Looks like no, we got false in the first test case. And the problem is here. So Python, if you do Python, if you do number at position, if you do something like this, -1, then it counts, right? And we don't, and that's what's happening here. If I equal to 1, then we'll get -1, so we'll get -1 at the end, which is actually the last element in the array. And so this check here, we need to check also that this is valid, right? That is a valid index. And that's pretty much, that should work. So let's run it again. Okay, so that seems to pass there. Let's test it. And that passes test cases. Yeah, so that's pretty much it. You can solve it a couple of other different ways, but I find this to be the most straightforward solution. Yeah, so thanks for watching and see you on the next one. Bye.